Hello, everyone. My name is Gabdulkhakov. I'm studying cognitive science at the Ruhr University in Germany. But originally, I come from Uzbekistan, so I'm also fluent in Russian and Uzbek. And in case if you have any questions, you can simply ask them in Russian or Uzbek or English. So in this tutorial, we are going to talk about multiple linear regression and polynomial regression. And by the end of this tutorial, you should be able to implement your own multiple linear regression and polynomial regression from scratch using Python and NumPy. So let's start. You're already familiar with this invariant form of linear regression, and in case if we have multivariate data, we can simply extend this form by adding one parameter corresponding to each feature in our data, where the parameter 0 or theta 0 corresponds to intercept or bias. We can rewrite this in a more condensed form in vector notation for a single data point like this, or we can rewrite fully in matrix form like this, where this X matrix is usually referred to as design matrix. So in order to be able to do this matrix multiplication, we need to stack ones in front of our data matrix, because it should correspond to the number of parameters in our model, and this ones will be multiplied with our bias. So first we generate our data with the following parameters, and then we will be trying to find an analytic solution for this linear regression for our artificially generated data. So here we generate our data, and actually 40 samples for this data. And if we plot it, we see this beautiful scatter plotted for x1, 2, and y variables. So in order to solve for this linear regression, we need to solve for this equation. It's an analytic solution for minimizing the mean squared error. And in Python, there are several functions that might come in handy for solving for this equation, namely the .t, the inverse function in NumPy linear algebra package, as well as this at operator that actually does the matrix multiplication. So let's start. In order to compute the theta hat, first we need to comment this exception, so it doesn't throw any exception. So here, the very first operation from here that we need to do is we need to transpose the matrix and then multiply it by another matrix. So in order to transpose the matrix, we simply do that by x dot t, and it will transpose that matrix. And then in order to do the matrix multiplication, we do that at x. We take this into brackets, and then we perform the inverse of this resulting matrix. This can be done, as I told earlier, with this linear dot inverse function. And p dot lin alg for linear algebra, of course, and then inverse. So great, we've written the code for the left part of this equation. So now we need to multiply it by x transpose and then y, and then we are done. We are basically computed the estimated theta hat. So simply we multiply it by x dot transpose. Should be capital letter. Please be careful about that. And then we multiply it by y. Yeah. We uncomment this, and then we print the results of our estimated theta hat values, and it should correspond to these values over here. So awesome, it corresponds to these values. It means that we obtained an analytic solution for this multivariate linear regression.